Hello and welcome to Semaphore Uncut, a podcast for developers about building great products. Today, I'm excited to welcome Dave Thomas. Dave, thank you so much for joining us.
Hey, you're very welcome, Tucker. How are you doing?
Great, thank you. You hardly need an introduction, but please just go ahead and introduce yourself briefly.
I am a very old programmer, basically. I have been writing code now since the mid-1970s, and every day I hope I'm actually going to get it right, and every day I disappoint myself. But I really enjoy our industry. I enjoy being able to create things. I enjoy having people use the things I've created. And along the way, I have learned a bunch of lessons, some of them quite painfully, and I've been lucky enough to be able to write some of those down in some books, including Pragmatic Programmer, Programming Ruby, a Rails book, and more recently, a book on Elixir.
Great. Thank you so much for that intro. Our paths have crossed a number of times over the last 10 years. Out of college, one of the first books were Programming Ruby. Then I dived into RSpec, and that was, the first book about testing. And then as our company went on and Semaphore developed, we switched to Elixir. And then, surprise, surprise, another book written by you.
So if you're going to be following whatever I'm doing, then I should probably warn you ahead of time that, I'm going to be recommending everybody switch to BASIC next year.
Visual Basic was my first programming language.
BASIC was mine as well.
Yeah. My mother signed me up, I was like maybe 13 or something like that for a course, and it was Visual Basic or Windows 3.11, Visual Basic 4. Yeah.
Were you one of these people that kind of fell in love with it at that point, or was it just one more thing that you had to do?
I was one of the guys that had to do something all the time. And in your kind of child's room, like one of the things where you have a full power and full control was that Visual Basic. So, there are no limitations there. Everything else being done in a physical world in terms of creativity required some resources.
Sure. I was kind of the same. I was in school and we finished our exams one particular year a month early just because of some scheduling, but they couldn't send us home. So they sent us across the road to a technical college that was experimenting with a computer science course. So we were the guinea pigs to go through that. And it was basic. It was not Visual Basic because we didn't have any displays. This was on one of those teletypes, with the paper tape readers and things. And I was going to go do mathematics at university. And I went into that class, and by the end of the first month, I just totally changed what I wanted to do. So I've pretty much been programming ever since.
Yeah, it's a completely different generation. All the time that you're talking about this part, I was thinking, like, how would I do anything without the visual feedback? It's not that it has to have a UI, but
Oh, I mean, you should try using punch cards, because at least the teletype is interactive. But when I went to college for the first year, the college didn't have any terminals. And we submitted our programs on punch cards. And they would come back wrapped in line printer output at the end of the day. So you'd put them in first thing, and probably 4 or 5 hours later, they'd run and then come back. So you got very, very, very good at desk checking your code because you couldn't afford to have more than like 1 or 2 runs, so you'd be late for your assignment. So it was seriously painful, but at the same time, I think it gives you a kind of discipline that you lose when you're used to just getting immediate feedback the whole time.
Yeah, you can become sloppy if you don't have to care.
I don't know if it's sloppy. I think it's just a different way of thinking about things. And I'll say something very interesting. I'm beginning to feel that again because I am in the middle of seriously trying to teach myself Haskell. I've known Haskell for a while, but I've never really kind of got into it. So now I'm kind of forcing myself to really do it thoroughly. And I'm finding the same kind of thing applies with Haskell that apply with punch cards. And that is, you do a lot of thinking ahead of time to get the types to line up and, to think about the actual structure that you're doing. And in the same way as with punch cards, that tends to mean things run. It takes longer to get to the point where you try it. But when you do try it, things tend to run a lot better or a lot quicker.
Hey everyone! Semaphore has published an open source book called CI/CD with Docker and Kubernetes. It combines just the right amount of best practices and practical advice for shipping cloud-native apps. Download your free copy today at semaphoreCI.com. I remember a lot of people saying that, when you write down something in Haskell, it usually works the way you intended. And yeah, I have very limited experience, but it is true. It is true. I wanted us to talk a bit about generally education and also that education connected with, how you write software and testing as one of the things which I think is really important. We are in this CI/CD industry. Like 10 years ago, it was obviously very important to us, very dear to us. One of the reasons why we decided to create like a Semaphore is a CI/CD tool at the end. And now, 10 years later, yeah, I'm getting old and I'm now complaining that people getting out of the college kind of don't know some things that I think they should. And we are doing some teaching and you did a lot of writing in your career. So you're in 40th year of your career or something like that. What's your take on that?
I think that what we do is an intensely practical topic discipline. I mean, we are one of the unique disciplines that sits between the totally abstract and the absolutely rock solid real hardware. And so really the only way to get good at something that involves that amount of diversity is through experience, right? You have to have experience. Now, if you are teaching chemistry or mathematics, then your experience is in the theory. Your experience is in the discipline of chemistry or mathematics. And so teachers who teach that are teaching theory, and that's absolutely fine. But in software, I think the majority of the teaching in software needs to be focused on the actual application. Not application as in the thing that you write, but the application of software to the real world. The fact that what software does is change things in the real world. And most of the teachers who teach software to students don't have that experience. Most of them are the same as someone who's teaching chemistry or mathematics. They've been in college, they probably took it as an undergraduate, they got their master's, they got their PhD, did some postdoc maybe, and did some teaching. And so many of them do not have experience of the kind of issues that you and I faced when we go out and we actually write software for real people. So I've always criticized university level education for software because of things like that. A few years back, I thought, well, rather than just sitting there and complaining about it from the outside, I wanted to go in and actually see what was happening on the inside. So I went and did some teaching at a local university. And it was both a really rewarding thing and also a very disappointing thing. It was rewarding because the kids that I was teaching, I mean, there was a mix, but I got so much enthusiasm and so much joy from them when things were working and they were doing things and it was cool. That was the reward in itself. But the downside was these people had never been shown any of the real world issues in software. They'd never been taught testing. And these were third and fourth year students who had never written a test in their life. In fact, the first class I gave, I said to them they had to write some tests. And one person gave me a program that output a string of ones and zeros and then told me that the program was correct if the output looked like this and gave me a string of ones and zeros. It was kind of scary. And it wasn't just testing. It was all aspects of, how do you write modular code? How do you design code? How do you even think about code? So they could tell you an awful lot about, NP complete algorithms, and they could teach you about or taught you about, parsing or whatever else. But when it came down to actually writing code, they couldn't code their way out of a paper bag. They were, really, really poor. So I'm not at all surprised that the students coming out of the college next door to you don't have testing experience. I don't think the majority of colleges teach their students that kind of thing. I don't think they teach them almost any practical skills. And when you look at it more as, is that a problem with universities? The answer is probably not, because universities are not supposed to be trade schools. They're not supposed to be the place where you learn how to, solder or how to, whatever. These are the places where you're supposed to be learning the theory, the background. And I think to some extent, we're suffering from the fact that, I don't know what it's like in Europe, but certainly in the States, everybody has to get a degree now. Doesn't matter what you want to do, you have to go to university first. So the value of university has been degraded by that, but the actual things that people do in universities hasn't changed. So if I was ruling the planet, I would get rid of computer science courses for everybody apart from the people that want to learn the theory and only the theory. And I would turn computer science education into an apprenticeship where you work alongside people for at least 2 years, and then you go do 2 years of theory in a university, and then go back out and do another 2 years apprenticeship. Because unless you do the 2 years first, you have no idea what the problems are that you're trying to solve. So, if I was a teacher and I stood up and said, everybody has to do unit testing, they'd go, well, why? That's just bogus. It's just one more rule. But if you go through 2 years and discover that it's actually a good thing to know whether or not your code works, then when you go back and learn about it, it's motivated. You actually understand why you want to do it. So I would love to see a 4-year or a 6-year course, which was 2 years on, 2 years theory, 2 years back in industry. But that's just me.
I mean, there are systems which are established, a couple of 100 years ago as universities and all that. And then there is what is happening really in the world outside. What you are describing, we could say that to some extent, in a bit different form, it is happening. I met a lot of people who haven't finished, computer science, who don't have computer science degrees, but are great developers.
Yep.
So I would say that maybe it can be taken as a proof of what you are explaining.
I agree with you 100%. And in fact, most of the really good developers I know do not have computer science degrees. A surprising number of them are musicians, but they don't have computer science degrees. And that's fantastic, except my son is a good example. My son resisted everything to do with computing his entire life, went to college, did a liberal arts degree, speaks really good Greek, ancient Greek, and then decided after he graduated, hey, I'm going to go do some software. And so he went to a boot camp and he learned all sorts of stuff there, went away, got himself a good job, and he's doing really, really well in the industry. But it turns out he actually doesn't know a whole bunch of the underlying theory. And he is like common people who are excellent programmers, but who couldn't tell you how many bits there are in a byte. And that is dangerous because I think we've created an environment where we have this veneer of high level. Everything can be, Visual Basic kind of level. Everything is high level. Everything can be done without knowing what's actually happening beneath the covers. In the same way that nowadays you can drive a car without actually understanding how all the systems work. But software is not yet at the level of automobiles. And unless you know what's actually happening underneath all of that, gloss, then you really don't know what's going on. And to some extent, you're just coding by coincidence. And it worries me a lot that there's a generation coming through who are very happy at programming using these high-level tools, but who don't actually understand what's going on. And, that's when we get issues like, systems that die because of exponential performance curves and things like that.
My brother finished veterinary medicine and is now a Ruby developer in Sydney. So there is another person who is exactly what you described. We don't often talk about, let's say, development. There are kind of other subjects that we have to patch up because we are very far apart. But yeah, I understand you that there are those fundamental basics that they lack. And sooner or later that bites and you can survive. But do you think that there is maybe a space where even you have a publishing company and work with a lot of writers, that there could be a curriculum that could be, set up I don't know how it will run and what it will contain exactly, but would help people patch up that what they're missing.
Yeah, actually, I wasn't even going to talk about this, but I'm actually at the very early stages of investigating just that. What would be involved. To my absolute shock, my son actually asked me if I could do like 90 minutes a week and show him some of the background stuff. And so I'm kind of taking notes on what I'm doing with him. And at some point may turn that into something, I'm not too sure what. The fun thing about that is that he wanted to learn about computer architectures and what was actually happening underneath, because he didn't know what a register was. He couldn't tell me what paging was or anything like that. And so I am actually currently in the middle of teaching him all about the PDP-11, because if you want to learn architecture without all the fuss and all everything else, it is the most gorgeous machine to work on. There's PDP-11 emulators written in JavaScript that run in the browser, and we're using a PDP-1170 emulator that runs in the browser faster than the original PDP-11 ran on hardware. Just to give you an idea of how far we've come. It's turning out to be a lot of fun, because for me, a lot of the stuff has become so familiar to me, it's almost like I've forgotten I knew it because it's now intuitive. And going back and having to learn it again explicitly is eye-opening. It's really good fun.
I'm glad to hear it. Sounds like a pretty rewarding experience, especially that you're doing it with your son. Hopefully it will see a light of the day and some people can also benefit from it later.
I hope so. I would like it to.
Hey, I'm going to take a quick break here and tell you that Semaphore has a new book out called CI/CD with Docker and Kubernetes. If you are looking to deploy cloud-native apps, it's going to show you the most productive way of doing that. And the best of all, it's free. Download your free copy today at semaphoreCI.com. I want to talk maybe a bit more about testing. We introduced it in a nice way. Okay, if you would stand up and say, okay, everyone has to write unit tests, everyone has to write tests, there is, some opposition, a pushback, to that. I kind of hope that, 10 years later, although I haven't been thinking about it concretely, now 10 years later, when I'm talking to customers, to developers, from companies using Semaphore, it's like, again, it's all the time the same, to what level should you test, how much should you invest in that. Especially when I talk to non-technical people in our company, it's about, okay, what percentage of companies are writing tests? Who is writing tests? Who is not? And I was lucky that I started my career in the Ruby community. For the listeners that maybe are not familiar with the Ruby community, it's one of the communities where they gave a lot to that community in terms of testing and that culture around it that was very, let's say, diligent and very dedicated to testing, writing good code, refactoring, and all that. So I would like to hear your thoughts around that, about testing in general, and why there is, I think, still pushing back that as a practice.
I think my thoughts on testing are possibly going to upset you a little bit. I think the word testing has become meaningless in the same way that, for example, agile has become meaningless, because people now use testing more as a kind of, it's like we have, some kind of superpower or, some kind of certification that says we're better because. And you talk about the Ruby community, and I agree, I'm very proud of the Ruby community, but there is a large faction of the Ruby community that have become religious about testing, to the point where, they write stupid things like, if you don't have tests, I don't even want to look at your code, or they will reject people on the basis of whether they test or not. And I've been to conferences where almost every single talk had some degree of testing in it, including one where the entire talk, it was labeled a talk on metaprogramming, but what it really was how to metaprogram matchers for RSpec or Cucumber or whatever it was, which really meant that we were like 4 levels removed from the actual code that we were working on. And all of their energy and their enthusiasm was not going into the code, but it was going into the things that wrote the things that wrote the things that wrote the tests, And to me, that's lost sight of what we're actually trying to do. For me, there are 3 reasons to write tests. We write tests to see if something works. We write tests to see if something still works. But to me, the most important thing is that we write tests in order to find out how something should work. We write tests as a design tool, as a way of thinking about our software. Most people are really bad at thinking in abstractions. And so writing a test is a really great way of forcing you to think of the actual concrete interfaces that your code will have. So for me, anyway, the biggest benefit of testing has always been it informs my design. Now, when people talk about testing, they very rarely draw those distinctions. The difference between a unit test, a regression test, and a design test are all just lost, and then we're just writing tests. And I think because of that, there's this confusion about what people should be doing and why they should be doing it. I think also there's a whole community that says testing is universal. We have to do testing whenever we do anything. But the reality is, no, we don't. The reality is that testing is a tool like every other tool. You need to have the experience and the judgment to know what kind of testing you want to write when. So I'll give you an example. I'm about 10,000 lines into writing a new kind of programming language / animation software. And I have some tests for it, probably got a couple of 100 tests, and they are testing various aspects of the parsing and everything else. I have not got tests. I would guess my test coverage is maybe 10%. And I am very happy with that because I am changing this language daily. I'm ripping out how I do things and replacing it with something else. And if I was to have tests for that, I would not get any work done. I would be spending all of my time refactoring all of my tests. And so I took the conscious decision. I'm not going to write tests apart from the things which are foundational, where I would feel really good just to know that they work after a change. So my tests are 99% regression tests. I don't run them automatically. Typically what happens is I'll only run them when something goes wrong. And then I'll say, okay, did I break something in the core? So I'll run the tests and find out. So I think that's a healthy way to think about testing. I think that saying people don't write tests is kind of like unnecessary. It's more like people don't know when they should write tests. I think that's the important thing that we should be looking at.
Yeah, and there are, as you said, very different kinds of tests. Thinking about just something that, clicks around your web application and checks if something will happen on a very high level will not really help you drive design of the application. However, some unit tests that you might be writing might help you with that. So, yeah, it's a question, how do you sell something as a practice? If I put myself in the category of more experienced ones who are like passing the knowledge on to some extent, we should maybe have different names for those tests because it's a very different thing, as you said. There are tests that are helping you drive design of your application and stay focused. And then there are some other ones which are, to some very, very abstract high level. On the other hand, also very practical, running some end-to-end tests, which are also verifying something, but their use case is completely different.
I don't think you ever convince anybody to do a practice. They have to convince themselves. So all you can do really is put together evidence. And the evidence is the stuff that you do, and you make it easy for them to experiment. Like, for example, the way a CI system kind of takes away the idea of, okay, I got to remember to write the tests before I deploy. You make it easy. That's why automated tests are a good step forward. You're making it easier to do the right thing. And I think that's the big driver for people. Once it's easier to do the right thing, then people will start to do it. But I think we also have to have the courage to say to people, along the way, you will come across situations where the tests slow you down. Now, there's 2 feelings that you might get. One is a kind of feeling that, this is really frustrating because, whenever I do something, the tests break. And that is not a fault of the tests. And we need to be explaining to people that that is a fault in the design of their software, and that we need to be better at showing how tests fit into the overall life cycle of software. Right? Tests are not like some gatekeeper of is the software good or not. Tests are an integral part of the ebb and flow of development. Then the other side of that is you may get situations like I had with my language thing, where the tests were genuinely getting in the way because I was actually having to rewrite. Because there was such a low level, whenever I decided to change that low level, it would blow every single test out the water. And so, I had to be very careful not to over-test that. And so people need to understand the motivation of testing before they themselves can become motivated to test. And I think part of that is explain to them when it's okay not to test.
If we are, let's say, producing a car or an aeroplane, there is that moment when it's done. It went to actually very rigorous testing and it's out. It's a finished product. And with the software, more and more, there are very, very old applications that are still around and running. And life cycle is just very, very different. And a couple of times in my career, I stumbled upon pieces of code that were written by someone, and didn't have tests. And that software is still around and running just fine. But once it falls in someone's lap, that person can find themselves in a very uncomfortable situation if that part of the software is not covered with tests. So there is that short-term, long-term struggle.
Yeah, I understand what you're saying. At the same time, maybe the mistake is to think that software should be long-lived. Maybe we should view software as being ephemeral. And rather than looking to build the one big application that has to last for 20 years, we build 100 small applications that come and go, but that work together, so that when we make changes, we don't make changes by going to the monolith and trying to change it, but instead we throw away the thing that doesn't work and we replace it with something that does. And personally, I think that's a healthier approach to development. We were talking before this started about the way that you switched from being a monolith to using microservices. And presumably part of the motivation was just it's easier to change when you have lots of small little things like that. So again, yes, if I had a monolith and if I intended it to be used 20 years from now, then not only would I insist on tests being present, but I'd also insist on a whole bunch of documentation being written about the internals that I wouldn't necessarily require if this was just something that was going to be used for 3 months and then thrown away. I would also require an incredibly solid amount of build support. I don't know if you've ever tried to run any software that was written 20 years ago, but even getting the tools to build it can be very, very difficult. Getting the libraries that it requires. I have software on 8-inch floppy disks. I would love to be able to get to it. But, apart from going out and building myself an 8-inch floppy disk reader or striking it lucky on eBay, good luck, So time is the enemy of everything. And we can either fight it or we can just accept it and rock and roll.
Yeah, it's that evolutionary part. And we will see what will survive as a practice. But there is also that component when a lot of things do survive and evolve and find new shapes. I mean, I'm now kind of trying to talk about generally the monolith and the microservices. I mean, we are in the area of microservices, and there are a lot of good things about that, and there is a lot of new tooling that has to be invented for that to be run easily.
Yeah, but think about the future. We are coming from a background like when I was first programming, where we have mainframe computers that you feed punch cards to and they produce output, right? And everything was a monolith just because that's what everything was. And we have gradually moved away from that. And then we've reinvented it. We've reinvented it with things like Rails and to some extent Phoenix and all the other more centralized ways of writing code. But at the same time, there's this movement going on in the background, which I think is going to become the dominant form of computing in the next 5 years or so. And that's the Internet of Things. Because in that model, we have thousands of little, small, unreliable devices that somehow miraculously network together and do something, and achieve something. And when you add a new device into the arena, it somehow knits itself in and, somehow cooperates with other things and gets stuff done. That's not microservices. It's a step beyond microservices. It's microservices, but with discovery and healing and security and all that kind of stuff layered on top of it. And I think that is the way that we'll be looking at building applications. Rather than building like the one big application, we're going to be building lots and lots of small things that can fit together in so many different ways and be personalized and customized in so many different ways. And if something breaks, you replace it, but you don't have to replace the entire thing. That, I think, is the world. I just don't know how we get there.
Yeah, and the moment that there are physical constraints, even if you would, by some crazy line of thought, think that you would create a monolith, no, there are physical constraints. No, you cannot. Those are independent physical devices, and they have to run completely independently.
Not even that. Because you have to assume that nothing is reliable, it changes the way you think about things, right? Everything becomes message passing because there's nothing is synchronous. You will always have to have some kind of CRDT type thing going on so you can ensure consistency across the entire thing. You have to worry about power, which means you probably can't be on all the time. And that changes the way you think about things. So it's not just a question of, you can't have monoliths because the hardware can support it. You can't have monoliths because the reality can't support it. It's a different way of thinking about it. It's very much like centralized control versus, some kind of cooperative or something, right? You don't have anything in the middle anymore. You just have lots of little small things cooperating. Now, from your point of view, think what that does to integration testing.
Not sure I have courage to think about that.
I think, to be honest with you, that is going to be a very, very big area, is trying to work out how to mitigate all of the various unintended consequences of all of these independent things cooperating.
Yeah, you have to guard in a lot of ways. And when you mention integration testing now, I was speaking with author of Continuous Delivery, and there was that part where we talked about monoliths versus microservices. And if microservices are not independently deployable, but you are testing everything together before deploying, then essentially you're not getting anything out of microservices. And that, by the physical constraints that you just in real world that you described around the Internet of Things, comes into the game that is, very unlikely that it's possible. I just want to add a story to this. A couple of years ago, I was on a conference and there was a guy from BMW explaining how they do a CI on a new car. It was BMW SUV called X5. And then they have a headlamp and they have a tail light and they have this and that. And it's impossible to have like 50,000 euros, car next to each developer so they can test it there. So it is maybe kind of ultimate, not ultimate, it has differences in terms of how it's connected, but things that cannot be tested together through integration tests. But at the end of the day, someday they start producing it and they ship it and it all works together. An example of those independent things where you must roll and move forward, even if you cannot test that all together all the time.
That's a different situation because effectively that's a bus. Yeah. And so they are developing components that sit onto probably a CAN bus or something else. I don't know. They're all different systems nowadays. And so they have a very well-defined physical interface and a very well-defined like level 3 interface, I guess, in terms of, 1, 2, 3, up to 7. So they know how to talk to each other. So once they got that sorted out, then they can write test harnesses that are purely software and make everything work. I think what I'm talking about is something slightly different, where you buy a BMW and then over the years, it turns into a powerboat. Okay, so a car is a slightly bad example because there's physical stuff that you can't do anything about, right? But being able to repurpose the electrical system of a car, for example, to do something totally different, is not impossible, all right? I mean, it's a set of general purpose computers that are all connected together over a high-speed network. You could make that do something totally different. There was actually a kind of cool video. Someone produced a video of a parking lot full of Teslas. I think it must have been some shipping center or something, right? So there were like 500 Teslas in this parking lot. And then Tesla issued a software update, and all of the cars started blinking one after the other, right? And to me, that was kind of symbolic of something really quite profound, because those cars changed. While we were watching them, they gained capabilities, right? It's a car. Cars are supposed to be fixed bits of hardware. But these cars suddenly gained, I don't know what, the ability to park backwards or something, whatever it was they gained. And that's what I'm trying to get to, is the idea that we can architect software in such a way that the underlying capabilities of the things change over time. So coming back to the idea of testing, then my question is, what does that mean in terms of testing?
Yeah, that's an interesting question. And answers are somewhere out there. And I think that some people maybe have answers to that to some extent right now, but they are not available to everyone yet.
I agree.
It's been a pleasure talking about all these topics. For me personally, I really look forward to hearing what comes out of bridging that gap for, let's call, self-taught developers, and what are those gaps that can be bridged in what way. I hope that we are looking forward to a book or a series of books in that area. And yeah, thank you once again for joining us and sharing all these interesting things.
Totally my pleasure. Thank you for asking me.